Hello, class.
Good morning.
Morning, how y'all doing? Mr. Marler? Hello?
Sir?
That's I thought that was Mr. Marler. Let's see who all on. Let's see. Oh, he's not on yet. All right. Mr. Park. Oh, he can't have a speaker. I forgot. I can't talk to him. Okay. All right. Everybody hopefully fared well through the storm. Anybody got any questions about the assignment? I haven't completed them yet. I have to submit the midterm grades. Uh, but on some of the assignments I saw where some people use two-dimensional arrays, and I thought I gave you instructions to where the year array was of int and the amount array was of double. So in that, you should have known that those two values couldn't be put into the same array because an array have what? Like data types. Some people still not writing using functions. All right, you got to use the functions. Some people have had a little issues with the code. I think I had one person where they had written a program, but their search algorithm was not working properly. And I think the one key thing in the algorithm was they for their search they had an int for the name for the the function. You know, rather than void, they were returning a value, but they had all of their code, and at the end they had return 0. So if every time you return in 0, you're returning the first record in the array, rather than return position, which was the value that you was gonna be assigning to position whenever you found that a value in that array listing. So those type things, some of those things occur. All right. Uh, some of y'all saw like programs. I saw, the design of it and whatnot. Like I said, I don't know if you're collaborating and working together, but they seem very, very similar. But I would tell you, and like I said, I didn't try to go into detail to see exactly and compare how much they were alike this time. But I will tell you, like I say, you're hurting yourself as we move forward because you're not really learning, the concepts. So it's just gonna get deeper and deeper. Because if you looked at the next program, uh, that program is based on the accomplishments that you've done in this program, and all you have to do is a couple of modifications. So, like I say, you'd have to know what you've written for those changes to be made. And if I, like I say, decide to go back and do some checking to see if those programs are similar in whatever fashion, you can get a zero credit, you and the person who have the like program. So, anybody have any? Yes.
Do you want us to just put our names in the chat again because the roll's still not working?
All right. It's what it said.
It says you just cannot assign roll at this time.
Oh, okay. Let me see something. Let me see something. Oh, I might not have it. Let me check something right quick. I thought I had fixed that. Let's see. So, Come on. Let's see something. Doing it wrong here. Yeah, go and put your names in the chat because I can't even get to the server. So everybody, just put your names in the chat again. Come on, come on, come on. Y'all let that run. Okay. Yeah, so then just put your names in the chat and we'll get to, let's go back. Okay. All right. All right. So anybody with any questions? Also they had some people, well, one or two persons. What they did was they had the search, not the search, the unsorted call function after they did the search. And if you do that, when you read in the data and you do the sort and you output the data, your data will be sorted already. You know, you won't give me the original data. Okay. So you were supposed to read in the data, then give it back to me, then sort the data, and then print out the sorted data, and then search the data, and then print out the record that you found or didn't find. What else about that? Yeah, some people, what they did not create a function to read in the data. They just read the data from the main file. And like I say, the instructions show you to read the data from the function. All right, everything you're supposed to read from a function. You were supposed to print from the function. You were supposed to sort from a function and even search from a function. All right. So you got to follow the instructions. All right. Okay. I'm trying to get back to my screen so I can share my screen. Let's see. And I don't see where it is. I'll close this up. Okay, let me see where I'm at in this class. Everybody can still hear me though, right?
Yes,
So
sir.
what? Yeah. So yeah, let me maximize. Let me maximize. All right, here we go. So now let's start with. I'll go back with chapter 9 because we had started chapter 9, right? We had started looking at pointers, right? Right. Everybody kind of understand pointers, correct? How many people looked at the program that I the new the with the were manipulating the pointers? Because even if you'd have looked at the chapter, it would have shown you it would have shown you programs that had that in it. So let's look at pointers. We had stopped off on pointers. All right. So we talked about pointers. We talked about and pretty much this is pretty much where we stopped. You know, where we was talking about how a pointer can be. Oh, man, I gotta turn off my phone. Okay. All right. Now, so if you look here, we had a value of X, okay? And if you look at this program, all right, where is it? Yeah, X. All right. We outputted the letter X, right? So then when we went to this 4, X went from 0 to 5. For X equals 0, X less than 5, X plus plus. So we're going to go from 0 to 4, right? That's going to output this part. But then what we did, what's happening here in this program, it's outputting every position of this particular array. So let's look at it. We said what? The name of the array is the what? Address. And then here, all you're doing is multiplying this time the byte size. So this would be the address plus 2 times, well, 2 times, 0 with the shorts, it's 2. 0 times 2, which is put you at the what? The very start of the array, which would be what? 10. So when X is 10, all right, and I print out, and remember this was dereferencing, and I print out the nums of X, all right, and I want that out, I want the value at that location, I'll get the value 10, all right, okay, but then we said what? Dealing with mathematics, your parentheses makes a difference. So if you forget to use the parentheses, what are you saying here? Okay, at that numbers is a pointer address because it's an array. So I'm saying at that starting point, now add X. X is 0, so 10, all right, which is whatever's at that starting point, plus 0, gonna give me 10. Okay, then X increments in this loop here to 1. All right, it prints out the 1. Then it says prints out the address plus 1 times 2, which will bump the memory address up to. All right, so now it says, okay, now I'm at this location, which for the second element, and now give me that value at that element, and now it's going to print 20. But if we look at it, if we wouldn't have put the parentheses around it, we saying numbers, which is the a pointer, which is the starting address, okay? And so this says, okay, at numbers, then okay, the address is the starting point plus X. Okay, so what's at the starting address? 10. So 10 plus X, which is 1, gonna give you 11. So that's how these numbers came about. All you kept doing was adding X to the number here, as opposed to collectively the address plus, the size, the X times the size of that data type. Anybody have any questions about that? Because like I said, it's different, and it can give you headaches if you do it differently. All right, and sometimes you may want to do this, but like I say, to manipulate the array, the entire array, and if you have it in the loop, normally this is what you want to do. You want to keep mopping up rather than say numbers of X, numbers, to print out numbers of X, you print out numbers plus X, and then dereference it and print out the value. All right. Questions? Any questions? All right. So here, what happens here? This is a program, and it tells us this program uses the address operator to get the address of an individual element of an array. So in this program here, all right, what it happens is it created it initialized the array, same array we had before, all right? But up here, it tells you that the array size is short, so we had to create a pointer of what? Short. Because I cannot put this array address, or the address of any element or this array into any other data type other than short. So I created a pointer called PRT_num that will be used so that I can take the address of each one of these elements of this array and store it in that pointer value. So if we look at this, look what happens. For x is 0, x less than 5, x plus plus. It's saying the address, the pointer address or the pointer is equal to, and look, ampersand number sub x. Because if we said just number sub x, we would get a what? An error, because number sub x is 10. But ampersand number sub x is the address of where 10 is located. Okay, so that will store the address in this pointer value variable, and then I can dereference it and print out the value at that address. And then it goes in and increment x again. Okay, so now PRT num is equal to ampersand num sub 1. All right, so now it's equal to a different address, which would be the address of this value. And now I can what? Print out that value. Okay, and it goes and goes through and print out each one. Everybody see what's happening? Everybody understand what's happening? Questions? Any questions? Okay, now no questions. All right, now let's say ask your questions. All right. Now it tells us the only difference between array names and pointer variables is that you cannot change the address of an array name the address that an array name points to. So what does that mean? So when I write my program and I create an array called students and give it a size, that's going to be the starting point, or the address assigned to that array will never change or can never change. But if I just create a pointer though, a pointer variable, then that can be assigned any different value long as it's of the same data, pointer address, as long as they're of the same data type. So that's all that statement there means. So look here, if you have double readings, okay, of size 20, total size 20. Now, the address that's given to readings cannot change, will always be the same throughout that program. The address given to totals will never change. It's gonna always, that starting address gonna always be the same, all right? But if you have double, and you got a pointer value called DPRT, it can equal to the address of readings or any location in readings, or it could be the address of totals, or any address, any element, address of any element in totals. All right, but the starting at the address of these cannot change. All right, so it's saying that this is legal. I got these two declared. I have two arrays declared, and I have a pointer declared. My pointer can equal to my first array. Oh, and then I can have another statement where it equals to the second array, which is the starting address. That's totally fine. But look what it shows here. The starting address of reading cannot equal to the starting address of totals. Never, because these are two arrays. They have to have their own what? Starting address. All right, or addresses. They have to be unique. All right, but then totals cannot be reassigned. Readings cannot be reassigned. You cannot reassign it to an address or from a pointer or from an array. All right, it has to have it. And normally, what this is normally, what the way we write is given assigned by the programmer when we declare this array. So when it look at double readings 20, the computer says, okay, I'm allocating this starting spot and these 20 elements where it would be what, 8 times 8 bytes times 20, and it's contiguous memory. So that's the allocation for reading. For total, same difference. It's a double wherever it starts, and then you got a contiguous amount of space for totals. But this DPTR, it's going to be okay. I have a memory location of 8 bytes, and it's located here, and it can change to whatever it needs to change to whenever I want to. All right. So remember, array names are pointer constants, cannot be changed. The array name cannot change it. Okay. They can only point to an array they represent. All right. So remember that. So in this program, and this is somewhat of what your program is going to be doing. All right. All right. If you read through this, it said the contents of pointer variables can be changed without without mathematical statements that perform addition and subtract, or say can be changed. Yeah, because that's what you're going to be doing. Uh, with mathematical statements that perform addition and subtraction. Now, so we have this program here, a small program. If you wanted to, and like I say, hopefully you've done it already. You went through the chapter and said, okay, well, let me look at this program. Let me type it in. Let me just see what's happening in this program. So let's look at this program. And let me make it larger so you can pretty much see what's going on. All right. So we have this program here. I'll just shift this over. It says this program, okay, and it should say allows you to manipulate an array by using pointers with addition and subtraction. Now, what does that mean? What it means is I can bump up to each element, but I also can go back down the array through each element. So every time I add, depending what address I'm at, I could bump up, and I can also bump down depending on what memory location I'm at. So we look at this program short, and we got a pointer variable called PRT underscore num. Okay, so that's a pointer variable that we create. Now, and that's something else I need to show y'all, because some people with my data dictionary, I don't know what you're doing. And then even with the documentation, and I don't know what you're doing. But just remind me toward the end of the class to kind of go over that again. Because that stuff, the documentation, you should get all 25 points. It should be a gimme. But some students, even if your program is wrong, document it. Okay, this is at least you're going to have the cover page. You're
and
going to
Mr.
have.
Sylvester,
Yes, ma'am.
I don't understand. I haven't been doing it because I really don't understand what you're asking on that. I mean, I see what you're saying, but I'm lost with that. And I haven't done any of them. And I'm like, I'm losing 25 points behind this.
That's half right. Mr. Gaddis. Mr. Gaddis. Oh, Mr. Park. Mr. Park can't answer. Mr. Gaddis.
Daniel, I don't think he's on here.
Okay. Mr. Park. Anybody in the chat right now?
Yeah, everybody is in there.
All right, I just don't go. Ask Mr. Park if I can pull up his documentation for the program, his submission.
He says that's fine.
Okay. All right. So what I'm gonna do, I'm gonna go back to here, and what I'll do, because I think his is pretty much okay. What he did on something, he used his and I'll just tell you before we start, his output, like screenshot, he put it in the category of output file. And he was kind of confused. Well, Mr. Vester, I thought that was the output file. No, we never written a program yet dealing with an output file. The output coming to the screen. It's not being written where you can pull it back up and look at it or do whatever. So what I'm gonna do, I'll go to Mr. Park, his okay, system running lesson. All right, so let's see, Mr. Park, Mr. Park. Oh, that's not here. Okay. So Mr. Park, where's Mr. Park? All right. So either one, I could pull up this one. Yeah, documentation. All right. So speed grade. All right. So I'll pull this up. So now let's look at this. The cover page. I want your name, the course name, my name, you know what I'm saying? Your name and the date, due date. How you design it, you can be fancy with it or what. I don't care.
Okay, Mrs. Sylvester, question.
Yes, ma'am.
Why are we doing that when we're putting it in the program or it's already there?
Okay, let me ask you this question. When you do work at your work, right? Do you just throw away an invoice or you just throw away whatever? What you do with that information?
I store it in a file.
Oh, thank you, ma'am. You file it for later what? Reference, correct?
Yeah.
This is why we do this. You have the program. Now, grant you, the program could be working perfect and whatever. But if you was working with a company and you was on a team, or you could be an individual, however, but let's say you're working with a team. Y'all worked on this program, y'all got this program running, and now it's filed away. Now, you don't only work on one program or one project. In a year's time, you may have several, maybe hundreds or maybe like say 50 or whatever, correct?
Yeah.
Now, if that boss tells you, oh, well, I want you to go back to project such and such and such, and I need you to modify something in it, what you gonna do?
I can go back into the file.
All right, you're gonna go back into the file. So now they're gonna have a variable name. What that variable name, what is used for?
To search your files.
No, but you don't know that. You're gonna have a variable name. Say, well, wait, what is this? You're gonna have to kind of go through the whole program to try to understand what that program is doing. Whereas what this is doing is giving a name of the program. This is the course. This could be something different. Could be company information, who you submitted it to, the team members or whatever, and the due date. So now, bam, that's information. Okay, grant you. The second part, oh, what was this program to be? What was this program to do? Okay, let's read through, and that's why I told you, give me exactly what I give you, because that way it's all there. You're not trying to reword it. Oh, write a program using what? Arrays. So now you know, oh, it's dealing with arrays to read in data from a data file. So it's like you're recording all this information as to what is associated with this assignment. So how the output should look. All right. So you got all that information. You're putting that in your mind and you're trying to understand what's going on. Then here is the actual code. So now you just copy the code and put it here. Sometimes you get in an interview, and I'm saying interview, but you get into a presentation, and you might not have the compiler, but you have the program. So you can discuss, okay, at this point, well, what we have a function to get it. Let's go down and look at that function, and this is what we're doing, blah, 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 whatever. You got what I'm saying? You got hard copy where everybody can view it at the same time, do whatever, discuss it, or whatever. You know? All right, that's the hard copy. Now, then here I told you to give me your header file. The header file could be the company information. And then the company might say, well, we want to have this information changed or whatever. Okay, you can look at it, write through it, modify whatever, say we need to change this, that, whatever. You got that information. You know where it is. Okay, what do we need to change? What do we need to add? Whatever. And then looking at this one, what they did, they loaded all of their libraries in the header file. So if you're dealing with another type of header file, you probably want to add it here if you're doing modifications to the program, rather than add it in the program if you did it here. Stuff like that. Now, see what he did? Well, really, it should have been after this. Mr. Parks, the source code, the output should have been here at this point. But what he did, he gave the output here. So now, Miss Bradford, now you got the date, time, whatever the program was due, and who all worked on it. You got the instructions of what the program was supposed to do. You got the source code of what how it's written. Now you got physical output to say, oh, this is what we came up with. All this in what? Document form. I didn't have to go to a computer and try to open up a file, run a program, do whatever. I have documentation where me and my team can meet on this stuff, make decisions, and then eventually we can go and sit down at the computer and do what we have to do. But you kind of understand what I'm saying? Yeah. Why the documentation? And now, grant you, it's not to say that this gonna make me a better program, whatever, but it's gonna help you to better put your program in order to where you know, well, hey, I have this program, I did whatever. What did I do? Oh, I got documentation. Oh, I did this, I did. Oh, okay, let me look back and I could check and see whatever. So that's what it does. All right. So it's just like having documentation as a user manual. When you buy a new television set with a remote, you have what? A user manual. The buttons are on the remote for record, for pause, for whatever, next channel, whatever. But you also get that user's manual that gives you more in detail what it is that that remote is used for.
Okay, so how you do a snapshot of that?
Of this? Well, yeah. Now I've had some people even just take a picture with their phone and put it.
Okay.
I don't have a problem with that. Long as you actually giving me that image of all the screen. Most people like this. This is done with some type of screen capturing software. All right. Whereas you may have, like I showed you, Snippet. Snippet is a tool that can capture information on the screen. All right. There's also the key combination, control and print screen. What it does, it captures that information and hold it into in the memory where you can open up like Paint and then do a paste, and it's gonna paste it in there. Then you could save it in a JPEG file or whatever. All right. So there's many different ways you can do it, and many different.
So basically, you could just copy paste, right?
No. You can't. I don't want that. See, I want to see a snapshot. If you do a copy and paste this into the document, and if you see something wrong, you could just click on it and change the number. You got what I'm saying?
Yeah.
But that image, you can't change that image. I can't change that image. You understand? I can't say, well, I'm a change that and tell them it's wrong. I can't do it. You can't do it, or whatever. You got me? Yeah. And what they did, which I liked, he did it. He gave me one where one was found, all right? And he gave me one where one was not found. If you didn't, it didn't matter, but I at least wanted to see at least one run of the output but normally you would want to show both, where, okay, this would happen with this scenario, and then this would happen with this other scenario, all right? Now, this is where the problem comes with a lot of people. Look, data dictionary is incomplete. I told y'all what I wanted you to do. Give me all of the user variables that was defined, but I want you to group them. Now let's go back and look at what I mean by that. Okay, so what's the first function we have? Oh, let's look at the program. What's the first function we have? Well, really, we have what? We have const row. So row should be int row, and row is a constant value for the rows in a two-dimensional array. All right, and I don't know why he did two-dimensional arrays in this program. You know, because the thing is, like I told you, this is one of them where year was int and amount was float. All right, so but then look, then you have column. It would be int, okay, column, and then constant value for the columns of whatever. Now, so here you would have what? Get a void with no data type. Get a, which is a function to get the data. All right, void. Okay, this show a show ARR to what? To actually show the data. Now, let's see. Let me see if he did whatever. Because let me show you something. And some people, what they did, they and I'm gonna go back to what I'm talking about. They did show original, and then they said show sorted. If you manipulating the same array, if you show it unsorted, you're going from 1 to 10, you show the array. But then to show it sorted, you can use the same function because you're passing what? The exact same what? Values. You understand? You didn't have to write two different output functions because what? You actually writing out the same variables, the name, the year, and the amount. So you didn't have to do two of them. So someone have unsorted output and then sorted output. You didn't have to do that. Just have one. Call it to print out the original. Then once the arrays are changed, then call it to print out the arrays again, which should be changed in the proper order. All right, so back to this. So all of these would be actually listed in the data dictionary. Then you would have int main. And we know that the main function is the driver function for in all C++ programs, right? Then you would have it would be int. It would not be void because it's coming from another location, you know, that other header file. Void head, and then this would be the header file that was loaded from the loaded header file. All right, so that's the function. But that would be what? Under main. Name would be under main. Another one, you have to put this in main. Even though I've said I declared it a void, whatever, show AR up here, I need to, within the main, I've used it in the main, I gotta list it again because I'm listing everything that I'm using in the main. So I'm using name, I'm using scan ARR, I'm using get ARR, I'm using name, I'm using scan ARR, I'm using row, row and column. Now I don't have to mention it more than once. See here, I got row here and I got row here. Once I mention row, I'm cool. I'm done. I don't have to keep mentioning row, but I have to mention it if I use it in that function main. Show ARR, all right? And I already have name, I already have scan ARR, I already have row. All right, sort ARR, I already have name, I already have this, I already have this. But when I put this, I'll put void, sort ARR, and what? Array to sort the data in my array name, scan RR, array name. All right, well, my array of name and scan ARR. So see, that's where he put his.
You're making this so hard for us. I tell you, when I get down pack, it's something else.
I gave you this at the beginning of the semester, though.
But I didn't pay attention to that header because I thought when I was doing the header and all of that, I thought that's what you were talking about.
No.
I'm doing a whole different doc that I'm putting in, I guess, Word format, right?
Correct, so that you can have documentation to either go back and reference to, or others can. Because look, just because you wrote a program or may have been working with a company and you wrote all these programs or whatnot, who's to say you're gonna still be working on that job or even in that capacity. You might be promoted. So the next person that comes to modify this code, you don't want them to have to check. Man, let me look through this program. What's going on here? Why did it? What? You got documentation, so that'll give you a leg up to understand what it is that program is doing and what it is you need to do to modify it. You got what I'm saying?
I'm just saying that I guess I'm trying to figure out the two difference in what you're doing here and when I
the code
go in to do my program. Why can't I just save that file that I'm already putting it in to a file?
No, I don't, because I don't want that. Because documentation, listen, if
that
you
is documentation, Mrs. Sylvester.
But all it is the program. All it is the program. Look.
You trying to fail me.
No, listen. I'll give you this point. When if ever you get in grad school and you work on a project, you're gonna have to write the code, justify the code, or whatever. But at the same time, you're gonna have to turn in documentation to support that what it is you're writing. If you understand what I'm saying.
Yeah.
Because just to have that code and say it runs, okay, it runs, but okay, where's the substance? Where's whatever? You know, and somebody coming behind you, if somebody had to pick up on what you've done, like say it with research or whatever, to add on to it, then all of a sudden now they got to go and learn. Because see, many times a person may not be working in the same language that you writing the code in. Yeah. But if you give them the documentation, then what? That'll help them and assist them into working in that other language. Even though they have the code, they got the output example, they got whatever, but then they got the documentation where they can actually use it to help them to move forward also in another language. You got what I'm saying?
Well, Mr. Park said that he still don't get how do I go about output? Wait a minute, I still don't get how should I do something about output file system.
There's no output of file. Tell him that. There's no output file because we did not write data to an output file.
Not this one.
Right. An output file is when you tell it to write something to a file. Did we do that? We outputted everything to the screen. That's just like me asking you, okay, write a program that will add two numbers and output the data to a certain file. Then you would not have a screen. The only screen snapshot you probably would have is it just bringing up the C++ line with the $, with the DOS prompt, because nothing would come on the screen. You would have to print out the data file. But we don't have a data file, so that would be just NA. If you want to put something there, or just don't have it at all.
All right.
Huh?
Okay, I got to go back and do. I mean, for everyone we did, I got to go back and do all this.
You got the what?
I have to go back and do the docs for program 1, 2, 3. I didn't do any of that.
You got to do what?
Go back and do this part here, what you're saying.
And do what? Do what?
I have to enter my information. I have to do with this here.
What's the due date?
It's past.
Oh, okay. All right. Okay.
So I still can't submit it?
Man, that's gone. That's gone. All right. So now, but everybody understand where I'm coming from when I talk about these. So everything in the main that's mentioned that you created, those variables, file names, functions, you got a list. But then look, this is another function. Then you would have void get ARR. Then list everything. and you look, you're gonna have what? NM. So now you see that NM is a what? A reference variable that's used in get ARR for what? For name. So you see how you're writing it to where a person can look at, okay, NM. Okay, now what is NM? Oh, all right, this is used for that. All right, SCR. SCR is really that scan ARR. That value is being thrown in here. But then you got COL and then you got row. You got to specify. You got index. Oh, what is index.txt? That's the file name that you're actually calling. What is in data? Oh, that's my file object that I'm using to read the data from the. So you see what you're doing? You're writing out all these different variables that you created so that a person looking at that documentation can know what actually is going on without having to try to run through the whole code to see what's happening. Or they might not even have to know what C++ is. Okay, this is a variable being used here, what it is. Boom. Oh, this is doing whatever. Right? So everybody understand that. So each function tell me all the variables being used, what they are, the end of data type.
So you're not going to put this back out there so I can put it in so I can bring my grade up?
Miss, we got more programs to do.
I know, but I want to go ahead and just catch up with this so I won't be so far behind.
I don't know about that. That's a lot of work. That's work. And like I said, you had time to question and ask, well, Mr. Sylvester, how is this? What is this? How whatever.
I just didn't go, oh, Mr.
And that's 25 points, right? All right. So I just wanted to mention that to you to make sure when you start doing your documentation that you do it in the order and you won't lose points. You'll know. And like I said, another thing is some people not putting them on each thing on a new page. I told you I don't want it all jumbled up, and now I got to try to sift through it to see where it starts, where it stops.
You're just trying to be so hard.
No, it's just trying to be organized. When you're looking at things, when you're with a company, you don't want to have to try to figure out where things start and stop, if whatever. No, everything starts on its own new section, on new page, and then you're moving forward.
But you fail to realize, and we're gonna move on after this, that I mean, in programming 1, I didn't do all of this. So
no, you didn't. No, you didn't.
That's why I didn't understand what you were saying when you went over it before, because I thought the documentation was the program that I was putting in.
But no, because when you saw that second assignment, you got program 1 doc, program 2 doc.
Well, when I saw the doc, I thought it was the information that I needed to do my program.
No.
That's what I thought. I didn't know that I had to do something.
Well, you take that one as a loss. You'll understand next time. So we'll move forward. Yeah, we'll move forward. All right. So let's look at this pointer and see what happened, how we can use this pointer variable to manipulate. Well, anybody have any other questions, though, before we move on? Any questions? All right. So,
I have one.
Yes. I'm listening.
For the program 3 document, you said the data dictionary is incomplete and should list all variables within each function grouped by functions. Could you explain that for me?
Yeah, please? But that would I just explained, but I'm gonna explain it again. What I mean by that is, the main is a what?
Main is the
is a function, right?
Yes.
So now these are outside the function. You still need to list these, in the sense that, this is global variables. So you list those. But then when you get here, main, right? Now you're grouping. I'm gonna group all the variables that I use within the main. Okay. So repeat what you just said, what you told me about list all the variables grouped by function, right? That's what you said, right?
Yes, sir.
So we grouping everything I'm using in the main. Okay, I'm using head, I'm using name, I'm using row, I'm using column, or COL, I'm using get ARR. I'm using a name. I already did that. You already did that one. Already did that one. I'm show ARR. Sort ARR. Already got show ARR. I already got all this. And then find ARR. All right, and I already have this. So that's all the variables functions and whatever that I'm using in the main. Then I'll go to the next one. Void get A. That's the next what? This is the next what?
The next function.
Wow, that's right. So now every variable, every user-defined variable that I use within that function, I'm going to list them. So what? I have nm, right? Notice what? In here, he used name. Oh, well, and then this one, he used nm, correct?
Correct.
So that's what I'm trying to tell you. So now in this function, now I'm referencing name with nm. So when you look at the documentation, you'll understand what is going on with the program. So then you got what? SCR, row, you got in data, you got index.txt, you got X, even if it's just for that for loop, let me know what X is being used for. You got Y, we got row already, we got in data already, we got NM already, we got X. All right, you got Y, that's a new one. So we got to list Y and what Y is being used for. We have in data, we have SCR, we have X, we got Y. He has show ARR. Even though we did use show ARR here, now it's also used where? Well, no, this is a different function. Scratch that. So here, we got another function. So now we starting to list what? All these variables that's used within this function. So the void show ARR, and so we got NM again, we got SCR, we got row. All right, then what? And we outputting those same variables, so we don't have to mention them again. All right. So well, this is just the headers. But then here you got X. You got to mention X. Even though we mentioned X in what? Get ARR, we still in show ARR, we want to mention X again. It's being used in here. You got me? Y is being used in here. Row is being used in here. Col is being used in here. You got what I'm saying? SCR is being used in here. So you understand? So even though I might use that variable. If I use it in all three functions, I want it listed in those three functions. So group the functions. You got main in this one, in a sense. You got get ARR, sort ARR. I don't know if you got print ARR. List all the functions in main or variables in main ARR, all the functions in get ARR, functions, all the functions and variables, user-defined variables used, and then print ARR. So when I look at the data dictionary, okay, let me look at get data. Okay, what variables is being used in get data? Oh, we're using X, we're using this, we're using this, we're using this, we're using this. Oh, okay, that's cool. That's fine. You got what I'm saying? Okay. Yeah. So anybody else, but group it by the function. Don't just say, oh, I use row, but I really use it in all of them. So once I mention row, I'm finished. No. Whichever function you use it in, mention it. You got me? You got to mention it. And like I said, just take your program and go line by line. Okay, what variable? And within that function, you don't have to repeat it. You understand? Because hopefully it has the same meaning, correct?
Correct.
Right, okay. Any other questions? And like I say, the documentation to me, is the gimmick. Now, I ain't gonna say it's easy to do because what? You're writing the program, then you gotta do the documentation. And then you wanna make sure your documentation matches with the program. So you got to make sure you get the program completed so you can turn in the documentation. But even if your program does not work, you can header file. Okay, cover page, done. This should be done. That's given. The source code, even if it's wrong, put it in there. The output, if it's wrong, put it in there. you're going through the motions of showing, okay, I've done at least this, and this is being turned in, correct? Then the output, the header file, that's given. You have that, and then your data dictionary based upon what you have already written, whether it's right or wrong, correct? You documenting what you have done. And at least you could get your points. But if you don't turn in nothing, then it's like, oh, if you just I'm gonna just put the header file and I'm gonna just put my cover page. Well, you're gonna lose a lot of points. All right, but document it. Now the thing is, you can't turn in documentation in and you didn't turn in the program, because you should have some type of output or something, whether it's right or wrong, showing that you done a majority of the work in the program, done some of the work in the program to get it working. All right. But like I say, this part here, that's a gimme almost. But a lot of people, they're not putting any effort into trying to get it done. And the statement of the problem, I'm telling you, all you need to do is give me back exactly what I gave you, which what they did. All of the instructions, all right? All of this, which is exactly what I asked for. And then the example of the output, that's a part of the instructions, all right? That's a part of what it should look like, okay? So then you say, well, okay, so if I input something, it should say not found or record found, and then give me the information, all right? So you got to show me and give me that information, all right? All right, so any other questions? Question?
Nope.
All right, so now this is the next program, your next programs, two of them. One of them going to deal with taking one of your programs and wherever you manipulating arrays, wherever in your program you manipulating your arrays, whether it's in your sort, in your print, your get, or whatever, your sort, I want you to manipulate it using what? The plus and the minus, all right? So now let's look at this little program dealing with only one array. We have a pointer, all right, of shorts, that's PRT underscore num, right? We have an array of 5, all right, implicitly declared, meaning that no size was given, but it's gonna count the number of elements and automatically assign the size, okay? Now, what it did here, it said PRT num is equal to numbers. Right here, we have just taken numbers, which is an array, which is an address. The name itself is just an address, and we storing it into what? PRT num. So now PRT num is at the starting address of numbers. Everybody got that? When I assign numbers to PRT num, it assigned it the starting address of numbers. So now, anything I do to PRT num, whether, increment, well, using the plus and the minus, is doing it against the numbers array, because that's the one it's pointing to now, all right? So now look at this. It says, okay, the contents, what we're gonna do, we're gonna try to print out the contents in ascending order. Now, what ascending order means, not necessarily the numbers that are in the arrays, it means the elements of the array, even though the numbers are in what? Ascending order. Everybody understand that? It means the ascending addresses. So if we look at this, we're saying for int x equals 0, x less than 5, which is the number of elements, all right, x plus plus, C out, and we dereferencing a PRT num, all right, where we actually what? Outputting the value at numbers or the beginning, which is what? 10. Everybody got that? So we outputted the value, but then look what happened in here. They said, okay, take that pointer and add 1 to it. So now what? That pointer is a what data type? Short. When I add 1 to it, I'm really adding what? 2 bytes, right? So my address is moving from this location to 2 bytes over. So now when I increment this, all right, X becomes a 1, and now I'm really at the second element, and I'm printing the second element. I'm incrementing again. It moves the addresses over to the third element. All right, X become 2, and then I'll print out the next element. All right, then increment again. All right, I move to the next element. X become 3, and I print out the value at the third element. Then increment again. All right, I move to the next memory location, and then increment X, which is 4, and then it print out the fourth, that element. So you see what's happening until this, when this get to 5, it's gonna say, oh, kick on out. All right, so it's gonna print 10, 20, 30, 40, and 50. Now, where is my, at the end of this, where is my pointer? All right, in this example here, where is my pointer once I print out 50? Where am I pointing to? Huh?
I'm not sure I get what you mean.
Okay, remember the pointer can only be an address.
Right.
So where's my address in a sense? Where am I pointing to after I complete this particular what I want to say? This loop.
You're still pointing to numbers, the array.
To what now?
The numbers array.
Yeah, no, but see, it pointed to the first one the first time through. All right, it pointed to here, correct?
Right.
And then it incremented 1 by 1, right? It pointed here. All right. It increment again. It pointed here, correct?
Correct.
It incremented again. It pointed here, right?
Right.
It incremented 1. It printed here, correct?
Right.
Then it incremented 1, and what happens?
It would go out of the...
Right. So it's pointing 2 bytes outside of the range of numbers. So you see how pointers can get you caught up? Because it'll point to wherever you tell it to point to, right? So I'm 2 bytes outside. So now when I go here to do my loop for descending, look what I had to do before I start printing. I had to do what?
Decrement it once.
Decrement it 1, which is 2 bytes, which is going to put me back at that what? At the 50. And now I can print the 50. All right? Correct? So I
Right.
decrement 1 for whatever, print out the 50, decrement, and then go back through, print out, decrement. So you understand what's happening. So it went 10, 20, 30, 40, 50, and it went 1 over, and then we had to come back 50, 40, 30, 20, 10, and it went 1 less, but it don't matter because we're not dealing with it anymore. Everybody understand that? Because like I say, this plays an important part in you getting the output. Because what could have happened? You could have got garbage here or a memory address here, and then 50, a memory address here, and then 50, 40, 30, 20. Right?
Right.
All right. So you got to look at pointers, man. Pointers point to an address. All right. It points to an address. Anybody have questions about this? But we're not going. The program you already written. We're not going to ascending and descending, but we're going to take it and increment to actually print out the value using that rather than using what? Subscript. All right. Rather than using a subscript, you're going to be using the plus plus and the minus minus. So that's basically in short what you're going to be doing with your programs. Rather than using subscripts for one program, you're going to use plus plus and minus minus, and then rather than using a subscript in the other program, you're going to use the array plus the index or plus the value, which could be the index value, and then reference the whole thing. All right. So those are the two ways you're going to be rewriting those two programs that you just done. All right. Take one, do it one way, and you're going to take one and do it the other. You'll see when you should be seeing it already. All right. So now it says, because PRT_num is a pointer of short data type, the increment operator adds the size of one. Did they say integer? That wasn't integer. Yeah, it is an integer, but it's short. An integer, which is short, to PRT_num. So it points to the next element in the array. Likewise, the decrement operator subtracts the size of one. I shouldn't put short integer, so you know. Short integer, which are 2 bytes, from the pointer. All right. Not all arithmetic operators can be performed on pointers. All right. You cannot multiply or divide pointers. Okay. We can add, we can subtract, but you can't divide or whatnot. So the plus plus and minus minus operators may be used to increment or decrement the point of a variable. All right. Now, that's not saying the array, right, class? The pointer variable. You got to get that in your mind. You got to create a pointer variable and assign the array value or the array address to that pointer variable. Remember that. An integer may be added or subtracted from a pointer variable. We looked at that, and then we did the asterisk. All right. This may be performed, okay, with the plus and the minus operators, or the plus equal and the minus equal operator. A pointer may be subtracted from another pointer, where you can drop down so many. All right. Because if I'm at byte 5, all right, well, let's say 0, 1, 2, 3, 4. All right, I'm with the 5th element. All right, what it's saying, I could subtract 2 from it to move down 4. All right, so that's all it's saying. So you can do the subtraction. All right. Now, pointers are designed to point to objects of a specific data type. Remember, we talked about that. You can't cross them. Just cannot do that. If I have a int pointer, I have to have it referencing an int address. If I have a float pointer, I have to have it reference a float pointer address. All right. Well, float pointer, I have to have it reference to a float data type address. All right. So when a pointer is initialized with an address, it must be the address of an object that the pointer can point to. So int to int, float to float, char to char, whatever to whatever. You can't mix them. So here we go, just for some examples. Int my value, okay? So my value is a variable. It's not an array, it's just a variable, and it's of integer. I have int, PINT, is equal to ampersand my value. What it is, they both is of int, that's correct. And then now my value ampersand says the address is equal to PINT. That's correct. But if I would have mistakenly left off the ampersand, I would get an error because I would be trying to put a value into an address. You got to remember. Now look at this. Remember the array, right? Ages is an array. So int ages 20. So this is an array of integer that has 20 elements. So PINT can only point to what? Integer, right? Addresses. So int PINT, which is a pointer, can equal to ages itself, which is a name, which is the starting address. All right. But I could have put a subscript here, and that then, like say, age is sub 3. Then what? PINT would equal to what? The address of that fourth element. Everybody understand that? Because ages is just the address of the what? The starting of that array. Correct? It's not the address of the entire array. The starting point, and then what? You can keep bumping up based on the size. So this one will keep bumping up every 4 bytes. All right? So, but look at this one. It says float, my float. And then, we got that int, and then PINT. And then we got ampersand my float, which is a what data type? Float. That address cannot be stored into PINT because it's of integer data type. So an integer pointer cannot hold the address of a float, char, string, or any other data type. Okay, it cannot do that. All right, that is wrong. Any questions about that? All right. Now, pointers can be defined in the same statement as other variables, all right, of the same data type. Now, the reason being is what? Normally a program starts from what? And we read from what? Left to right, correct? So if we read this and the computer is actually calculating this or processing this, it's going to say what first? Int my value. So now my value is known. Then asterisk PINT, which is a pointer, is equal to ampersand my value. This is valid because my value prior to that was introduced as int. Okay, so as long as you have it in that logical order, it's okay. All right, so you can do it, all on one line if you choose to. All right. The following statement defines an array called readings, all right, and a pointer called marker, which is initialized to the address of the first element of the array. All right. So what happens here? Int readings. All right. So reading is of int, but now we just put a comma. So anything we put after that comma, marker is of what data type? Is of int, right? Just like this one is of int. Just like if we do int x, comma, y, comma, z. All of them are what? Integer data type. So marker is of integer data type. So now we have marker as a pointer, reading as an array, which is the name is a pointer. And now we take in what? Readings, and the address of readings and the starting address of reading and storing it into marker. Okay? Everybody got that? Now, it says, however, int PINT ampersand my value. What happened here? I've introduced my value and trying to get the address of my value before I even told the system to allocate space for it. So what? I'm going to get an error that my value, what? Undeclared, undefined, or whatnot, right? So I have to take this and move it above this so that the system knows that, oh, my value, okay, it's a variable. I've allocated space for it. Okay, so now I can, and it's of integer, and now I can take its address and put it into PINT. So like I say, the logical order in which you list your statements does make a difference, okay? It is invalid because my values has not been declared, okay? But because it is used, it is used to initialize PINT, all right? Comparing pointers, okay? If one address comes before another, it can be greater than the other. Well, it'd be less than the other, all right? Because what? Addresses will normally what? Increase. You kind of look at it as if you're going, how would I say it? You got to do it in ascending order. Going down a street and all of the addresses are increasing, all right? The address that you're at now would be less than the next address that you get to, all right? So you could kind of take that analogy. So if one address comes before another address in memory, the first address is considered less than the second. Okay. C++ relational operators may be used to compare pointer values. Okay. So you can use the greater than, you can use less than, whether it's equal to, not equal to, greater than equal to, less than equal to. And you say, well, why you want to compare whatever? Sometimes you may want to check to see if a pointer is equal to an array. You understand? So look at this. It says, if one address, well, we said that already because it's for less than whatever. So we said that. So look at this. This is just a symbol or diagram of that reflects an array, all right? An array of 5 integers. So what? Every 4 bytes, we'll get to the next what? Memory location, all right? So the name of the array, well, what do they call it? We call it right here ARR. So it's shown here. ARR is the array. So ARR sub 0 is at this address. ARR sub 1 is at this address. And this address is greater than this address, okay? Now, we'll look at it and we'll see it. I'm about to ask you a question. So let's look at this. Because the addresses grows larger for each subsequent element in the array, the following statements are true, okay? And let's look at this. So that's like if we was writing programs, but I'm saying this would just be concrete, would be true regardless. If ampersand ARR sub 1, so now it's not asking about the value at that location, it's asking if the address of that location. So if ampersand ARR greater than ampersand ARR sub 0. So is ARR sub 1 address greater than ARR sub 0? Yes, based upon us saying what? If one address comes before another address, the memory, in memory, the first address is considered less. So this will be true. ARR sub 1 address is greater than ARR sub 0. Now, so let's look at this. If ARR is less than ampersand ARR sub 4, I want to ask this question. Why I just asked ARR? Why would I ask if it's just ARR? Why did they just say ARR?
Just pointing to the first location anyway.
The first
data location, the sub-zero.
The first, for that word we give it
element, sorry.
No, looking for the A. Let's begin with an A.
Address?
Right. See, the name of the array is the actual what? Address.
It's the actual address, yes.
Right. So that's why you don't have to put what? Ampersand here. It's asking what? If ARR sub 4's address greater than ARR. ARR, this is the starting point. ARR sub 4 is here, so it is greater. All right? So, because remember, an array name is an address. All right? So now, it asks us, is ARR sub 2 not equal to ARR sub 3? That's correct. Neither one of them are the same, right? None of them should equal to each other. None of the addresses should equal, because what? You're bumping up by 4, because it's an integer array, right? So comparing two arrays are not the same as comparing the values. Remember that. The values the 2 pointers point to, all right? So look at this. If PRT1, which would be a pointer, is less than PRT2. So now you're asking if 2 pointers, PRT1, if it's less than PRT2. So that's asking if the addresses, you're comparing the addresses, and one less than the other. But here, all of a sudden, when we use this asterisk in front, we're dereferencing it and saying what? Is the value what that PRT1 points to is less than the value that PRT2 PRT points to? Everybody understand that?
Yes, sir.
Everybody got me? Okay. So this one just checked for the address, but this one checked for the actual value, right? But you got to understand, just because this is 1 and that 2, that doesn't mean that 1 is less than 2. Everybody understand that?
Right.
Because PRT1 could be pointing here to this address, and PRT2 could be pointing to this address, right? So don't get confused with those numbers, right? It's where it's pointing to. And that's what somewhat makes pointers a little confusing, than just writing out code dealing with the actual just variable names and whatnot, where you can say, well, this variable is equal to this, and I know that value. No. Yep, you got to deal with you're dealing with addresses, all right? So looking at this, check this program. Let's look at this program, and it's dealing with using pointers. Yeah, I'll just leave it like this. All right, so it says this program uses a pointer to display the contents of an array, of an integer array. All right, so let's look at this. So we have an array set to 8 elements. All right, it's called set, but we're creating a pointer of int that is set to the starting address of set array. Okay, so now the starting point here and the starting point here is the same. So this is pointing to this particular position at this time in the program. So now look what they did with this loop here. So it says, okay, the number in the set R, and now it says cout ampersand, dereference num. All right. So now it's going to display what? The first element. All right. Now, but look at this. It says while numbers is a what? A pointer. Pointing where? To the starting value. All right. So, or the address of the starting value. So numbers, all right, while numbers is less than ampersand set 7. How many elements we have in here?
8.
8, all right? So we going from 0, well, we did the first one already. So now, well, it's gonna say less than 7. So 1, 2, 3, 4, 5, 6, 7. So what happens is now it says while numbers less than ampersand 7. So what happens is it says, okay, at this location it's 0. It printed this out. Okay, now is this element, well, where is it pointing? It's still pointing now though. It's still pointing now. So it outputted the first one. So now it's gonna say what? If numbers, which is at 5, is less than this address, right? Because ampersand sets of 7 is the subscript sets of 7, but the address. So is this address less than this address? Yes. Now it says what? Increment num, right? So you're gonna go from here to what? To here, right? And you're gonna stay in that loop, and you're gonna keep on printing out nums. You're gonna keep out printing out nums, all right? It's gonna keep out printing out nums, all right? So now, because what happens is when it increment, it's gonna print, and then it's gonna come back, increment, and print. So it's gonna allow us to print that last one. Because remember, in that last what I want to say, example we had to decrement before we start printing again to go back down, right? But this one, they printed the first one, and then now they just incremented and printed all the rest of them. Everybody got that? So that way, it printed all 8, and then when it got here, all right, it says, okay, now we want to print them out in reverse. So now what we did, we know that set is always the what? The beginning, right?
Right.
The key of set. So numbers is all the way to the what? To the very end. The pointer went from what? Here, kept adding. Look, we kept adding num plus plus. So it kept on plus plus, plus plus, plus plus, plus plus, plus plus, plus plus, plus plus. Now, once it printed out the last one, when we get to this C out here, we're at this point, so it's going to print out that last one, and then we asking while nums is right here, is greater than set. So it is greater than set. We take one away, it moves it here. All right? Take one away, it moves it here. Take one away. So see how I keep going down further and further and further down. And then what? Then this one say, okay, see out, asterisk nums, and then quit. So that one gonna print that very last one, because this asks if it's what? Greater than. We never printed when it was what? Equal to. Right?
Right.
Let's see. Wait. No. Right. No, well, we did it when we subtracted inside of here. So it did it automatically. Is it less than? Is num greater than? Yes. And we subtract by 1, it could be equal to, all right? I mean, it could be 1 or greater. We subtract, and it goes to that equal to, but we never checked yet, and it prints, okay, is equal to, it kicks out. Okay, so that's what happened. All right, but you see how you can use, inside of your while loop, you can use the comparisons of the pointer address and the address of a particular element, because we didn't have to go to 7, right? We could have went to 4, right, and used just part of the array, correct?
Right.
We didn't have to use the whole array, right? So see how you can manipulate your arrays using a comparison, all right? Logical comparison. Now, pointers as function parameters. And a lot of times that's when we're dealing with passing something as an argument. But we know what, and we'll get to it. An array itself is a what? An address, right? And we've been passing arrays in our program, no problem, all right? But well, let's look at it. And a pointer can be used as a function parameter. It gives the function access to the original argument, okay? Much like a reference parameter does. You can pass an argument by reference, all right, by using pointer variables as the parameter. Reference variables are much easier to work with, all right, than pointers, because reference variables hide all the mechanisms of dereferencing and indirection, all right? This is useful when dealing with string, and the C++ library uses many functions that uses pointers as parameters, right? So look, let's see some pointers as function parameters, right? So here we go. Just like when we did the ampersand allows us to pass it by what? Pass something by what?
Reference.
By reference. When we use the asterisk, we know that we passing what? Passing a pointer. Everybody got that? So if I do int asterisk comma int asterisk comma int asterisk comma int asterisk, that means I'm passing so many what? Pointer values, right? Addresses, correct? So that's just an example. If I have a function called get number, I'm telling it that and I'm using it as a prototype. I'm not returning anything. My function name is get number, and I'm gonna be passing to that function a variable of an integer that's a pointer. Okay, that's all it says. And the same thing for double. I'll be passing a pointer value to that function. Okay, and now in the function call, all right, you use this get number ampersand number, because what? I can't just pass number now in my, like say if I'm in my main and I'm saying, okay, do this, now call the get number. No, I can't just put number. Well, I can, if it's an array, I can do that, right? Because an array is an address. But if I'm passing a pointer, you know, I need to pass it using that ampersand, so it's knowing that what? In here, that pointer address is being passed to that function, okay? Not that value, okay? Because if I take this off, then all of a sudden I'm saying I'm passing a value, which cannot be stored in what? In an address. Okay, so you got to remember that. All right. So now look here, when you're defining the function, when I'm defining the function, same thing again here. Look, int, right? Int, asterisk, which says is a pointer, but then asterisk. Now here I have to introduce what? The variable itself. So I'm passing numbers, the address of numbers, into a pointer called val. All right. And all it did here in val, it says, okay, I'm dereferencing it, and I'm multiplying whatever values at that address by 2. Everybody see that?
Wait, how's it multiplying it by 2?
Right here, times equal.
Okay.
Yeah. So I'm saying that see, this here is just what? The actual pointer and dereferencing it to say, okay, get the value. Okay, get the value. And then times equal, that says value is equal to value times 2, or val times 2, my fault. Val times 2. So whatever value that's there, say 10 is there, it's going to say 10 is equal to 10 times 2, but it's dereferencing that value. It's going to get the value rather than the address. Because now if I take this off, I would get an error. You understand what I'm saying? Because it's trying to multiply, and you can't multiply a pointer, right?
Right.
And we talked about it, you can't multiply. Okay, so now look, this is the program. I broke it down and showed it to you. The prototype. If I want to pass a pointer, I'd have to do the data type and the pointer, because it don't have to be int. Like I say, whatever the data type and the pointer. When you're calling it, when you actually from the main function, you're calling it, you have to use the ampersand, all right, because you're passing the address of that actual value. You don't want to pass the actual, try to pass the value. And then in your function header, you have to what? Introduce the variable name. Now you could have used number again, but like I say, sometimes it makes it confusing for you to know where number is being used and what it is. But it's no problem, because when I introduce it here, it's a new variable anyway. All right, different scope. All right, so they got it as val, and then like I say, they multiplied it. So let's look at this program. If you look at this program, yeah, that was it. This program, it has the function prototypes here, which what we looked at. All right, int, ampersand. Then here in our call, we're calling it from the main. All right. And number is just an integer variable. All right. So we calling get number, and we're gonna pass number, but we're gonna pass the address. All right. So we passing that address, and then we're going to get number, and we passing it into input. Okay. Remember the other example? Well, we didn't see the get. So we passing it into pass it into get number. So we getting the value in a sense where we say enter an integer number. But what they did, they dereference here. See here? So you got ampersand number. So it say, give me that value. It's not saying the address. Give me that value. So whatever value you put in here is going to be stored at that memory location. Okay? Then it's going to return back to the next executable statement here, which is double value. So now we pass in a what? An int value. Oh no, that's not here. Where's double? Right here. That's just the prototype. Here's double value. So here's saying double value, ampersand number, is taking number and is passing it to double value into val, the address at least, into the address of val. So everything in this program is working with one address, right, where number is located. But if you notice, it's dealing with input, it's dealing with val. So now the addresses, right, not the actual value. So now it says, okay, bring in that address and store it in the val, and then dereferencing it, take val, okay, whatever the contents is, multiply it times 2, and store it in to val, which returns back to the main, and then what? it was whatever was done at that address going to be done in what number, and now we can output the value that was calculated. Okay? Question. Everybody see that?
Yes, sir.
All right. Now, and like I say, there's some other programs, but that's the chapter. So what I'm going to do, like I say, the assignments, what I made that assignment do?
Monday.
Monday, right?
Yes, sir.
Yeah. So you should have been working on it. Continue. Like I said, I gave comments in the programs. I got a few more to grade for the second program, like 4. But look at your comments. Try to get your program working, because you got to have that one working to actually do what I want you to do in this one, right? And in this one, like I say, all you're gonna be doing in one of them, you're gonna be using the plus and the minus, where you actually print out your data and whatnot, and reading the data and whatever, and wherever you're manipulating your arrays. And well, I'll say this. I want you to use the plus and minus in the get and the put. The get and the print. And like I said, if you manipulate and whichever one you're using it at that time, stay with that one. Like say, if you're using the plus, stay with that one in whatever I'm telling you. So if you're using the plus and minus, modify the get function where you're getting the data. I don't want you to use subscript. And the put function where you actually printing out the data. If I'll give bonus points if you manipulate the sort and the search using the plus and minus. Everybody got me on that, right?
Yes, sir.
How many bonus points?
10 points.
Keep
That's points.
I want the 25.
That point, yeah, you won't. I want $1 million, but I can't hit them numbers right. But like I say, use it in the get and the put. That's the program. That's the assignment. But if you do it in the sort and search, you get bonus points. Then when you do the other one with the parentheses plus X, dereference. If you do it that way, I want you to do it in the get and the put, and then if you do it in the sort and search, you get a bonus point. So what I would do it with the get and the put first. Make sure I can get my points, all right, and then put that aside, make a copy, and then try to work on the other one with a new copy and a new copy of that one. And if I get it right, I submit it. If not, hey, I know I got my other one done. But don't try to get it right with what I asked for and then try to do the bonus and to get all screwed up. And you're like, oh, Mr. Best, I had it, and now it's doing, I don't know what it's doing. It's not giving me the data, and then you don't get your points. All right?
Okay.
All right. And what I'll do, I'll post the test. I'll post the test for this chapter, because I don't think I post this test yet. All right?
Ready?
All right. So y'all have a good one, all right?
You too.
You too.
All right. Bye-bye.